Good evening. Namaste, Ahana, Samaira. How are you?
Good evening, sir. Vibhota. How are you?
Are you okay?
Yes, sir. We both are fine.
Sorry.
Yes, sir. We both are fine. How are you?
Okay. I'm also doing good. Thank you very much. Yesterday we practiced a few questions from exponents on real numbers.
Yes.
Did you practice them again?
Yes, sir.
Are you there?
Yes, sir. I'm there.
Invisible. Why invisible? Should we start?
Yes, sir.
And how is audio and video? Sound is good?
Sir. Yes, sir.
Okay. So there will be a few more questions on exponents on real numbers. We'll practice a few more questions. You already know the basic rules involved in the exponents. So laws are already taught to you in the previous grades 6, 7.
Yes, sir.
Just one thing you have to take care, the application. Whenever you get a question, you have to make sure you apply the properties correctly and instantly. So question number 1. You have to simplify this expression x raised to the power a times b minus c, x raised to the power a times b minus c divided by x raised to the power b times a minus c divided by, the whole thing is divided by x raised to the power b upon x raised to the power a and whole power c over it. You have to simplify. Start and submit your work within 3 minutes. Now you should submit. It's only 15 seconds remaining. Did you complete? Did you submit your work? Whose is this?
Sir, Samara.
Okay.
Sir, I have also seen.
Okay, just a moment. So, Samira, you multiplied A inside it here with B minus C. AB minus AC divided by here x power BA minus BC. That's good. And no change presently here. Here no change. You multiplied this BC AC. Okay. Then here you made it reciprocal. AC goes above, BC down. You got finally x is equal to
No,
AC.
sir, I was taking both common.
Okay. Okay. So suggestion is that if you don't make any change in a step, that means you are going to increase the length of your solution. Like here, say you made no change in this step. This is as it is, means your length of solution is going to be increased. Here you did not make any change, so the length is increasing. This is the suggestion. And yes, work is correct. Work is correct. You need to be quicker and precise. Okay, Samira?
Okay, sir. Sir, I have seen, but I have not completed yet.
No problem. Be quicker and precise is the suggestion. And this is from Ahana. You also have multiplied A inside, AB minus AC, ABA minus BC, and here no change, no change. So suggestion is that in every step, make sure you are making some change. Don't keep the things as it is. If you keep the things as it is, the length of the solution will be bigger. Unnecessary time will be consumed. And then you reciprocated. No, that's the same. So here again, there is no change in this second
You are not audible. Hello, excuse me, sir. So you're not audible.
Can you hear me now? Can you hear me now?
Yes, sir.
X raised to the power AB minus BC. I made the same change as you made here, and after division sign also I'll make the change, x raised to the power BC divided by x raised to the power AC. Then the first fraction, I'm making the another change here. What change? Notice they have the same bases and their powers are different. What do we do in that case? If we have same bases like a power m divided by a raised to the power n, if we have same bases in numerator and denominator but different powers, what we do is numerator's power minus denominator's power is written with the same base. That's what I'm going to do here. X raised to the power numerator's power AB minus AC, and then I'll subtract the denominator's power. Denominator's power is AB minus BC, and don't forget to put the bracket if it is a minus sign, if you have to subtract an expression. Okay, now division sign comes, and then the second term, again the same rule I'll apply here, x raised to the power or let's first make it a multiply sign. No need, I'm keeping division only, and then x raised to the power numerator's power BC minus denominator's power AC. I hope there is no problem till this.
No.
Okay. Now I have to open this bracket here. Before that we have minus sign, so sign will be changed if I open the bracket. X raised to the power AB minus AC minus AB and then plus BC. And now notice here, after division sign I have x raised to the power this, and we know fraction like this or division sign are the same things. A raised to the power m divide a raised to the power n is the same thing like this. So we treat this in the same manner, a raised to the power m minus n. So after division sign, this is in denominator. Can we subtract the power of x from this? Yes, I am putting a minus sign, then making a bracket inside which I will write denominator's power BC minus AC. Tell me if you got it or not. Now I'll open this bracket, x raised to the power AB minus AC minus AB plus BC minus BC and then plus AC. So now the base is alone, and this much long is the power. Let us check if we can cancel out the things. Yes, AB positive and AB negative, cancelled. AC negative, AC positive, cancelled. BC positive and negative. Cancel. What we have then in the power? What we have the power? 0. Everything cancels, nothing is remaining, that means 0. And finally its value is going to be 1. Any doubt?
No, sir.
Okay, let's move on to the next. You can note down the question along with me. X raised to the power a upon x raised to the power b has a power a square plus ab plus b square. There is a multiply sign here, and then x raised to the power b upon x raised to the power c whole raised to the power b square plus bc plus c square. And then the third factor is x raised to the power c upon x raised to the power a, and whole power is c square plus ca plus b square. You have to simplify. I hope you have noted the question. So now you can start and submit the work within 3 minutes. 3 minutes is about to be finished and you have not submitted your work. See, it's very easy. It's not too much difficult. I'm setting the time. I'm doing it in front of you. See how much time is required genuinely. Genuinely. Not just because of being a teacher. I'm showing you the normal speed of doing this. Time started and see I'm showing it. First step is this only. Next step, x raised to the power a minus b into a square plus ab plus b square. I hope it's not a problem for you. You already know power will be subtracted, a minus b, and power to the power, double power, will be multiplied. So a minus b multiplies with the another power. Then same will happen with other two factors.
Yes.
Here b minus c with b square plus bc plus c square. Now comes the third one, x raised to the power c minus a into c square plus ca plus b square. Did you get any clue after this?
Yes.
What is that? No, actually this is an identity. A minus b into a square plus ab plus b square is a cube minus b cube. Second one is same as b minus c into this b cube minus c cube into the third one x raised to the power c cube minus a cube. Now what we see, you don't know this identity?
Yes.
Oh, okay. Okay. Now we have the same basis. Yes, you are also right. If you just multiply them all, then also you'll get the answer. If you don't apply this identity, if you have not studied it, leave it. So now at least you understand we have to add all these powers, right? Because their bases are same. So let's multiply using distributive property, then plus, then multiply these two, then again plus, and then multiply those two.
Yes.
So a cube, a into a square, then a into ab, then a into b square, then minus b with this, minus a square b, minus ab square, minus b cube. I am writing the second one after multiply sign itself, x raised to the power b cube minus plus b square c plus bc square minus b square c minus bc square minus c cube, the second one. Now the third one here, c cube plus c square a plus b square c minus c square a, it should have been a square, by mistake I wrote b square. So it's a square c minus c square a minus c a square minus a cube. Now in each of them what we see, a square b positive, a square b negative, ab square positive, ab square negative, b square c positive, b square c negative, bc square positive, bc square negative. Similarly all these terms got cancelled. Now what we have, x raised to the power a cube minus b cube into x raised to the power b cube minus c cube into x raised to the power c cube minus a cube. Now you just add these powers together, a cube minus b cube plus the second power b cube minus c cube plus c cube minus a cube. Now notice all these are getting cancelled. A cube with minus a cube, b cube minus and plus, c cube minus and plus. So what we have, x raised to the power 0, that is 1. So I had to eliminate a step and I have to explain this, and this is done in this time. So there is nothing to stop anywhere, I guess so. Do you think? There is no stoppage. It's non-stop process because everything is already clear what to happen next, right?
Yes.
Everything is clear what to write next. So there is no point of stopping. 3 minutes I think is sufficient. And now you learnt one more thing here, that if you multiply these two brackets together, you will get a cube minus b cube, because you noticed here 4 terms in between got cancelled. There were total 6 terms, out of which 4 terms got cancelled, remaining a cube minus b cube. So now onwards you can remember it as an algebraic identity. A cube minus b cube is equal to a minus b. First bracket minus because of this minus, and the second bracket a, all terms positive, a square plus ab, not 2ab. Be careful, it's not 2ab, don't be confused, because there is another identity, a plus b whole square, in which you write a square plus 2ab plus b square. So you may be confused, but notice 2 doesn't come here. A square plus ab plus b square. Well, this was one question. Next, let's move on to the next. Next question is here. If ABC is equal to 1, then 1 upon 1 plus a plus b raised to the power minus 1 plus 1 by 1 plus b plus c raised to the power minus 1, again plus 1 upon 1 plus c plus a raised to the power minus 1 is equal to what? You have to evaluate. The value of ABC is known and we have to find the value of this expression. So take this time, you have 4 minutes to finish it. 4 minutes, I'll wait. Start.
Sir, I have sent.
Sent. Okay. Whose work is this?
Just a minus.
Okay. Ahana, are you done? I'll wait for you.
Sir, I have seen.
Both of you got different answers. What did you do? 1 plus a plus b raised to the power 1. You wrote 1 for everything. For a, for b raised to the power minus 1. So you think a is equal to 1, b is equal to 1, c is equal to 1. Right? You have used this, right?
Yes.
But this is not given. This is not given. It's ABC equals 1. The product of 3 is 1. Their separate values are not given. How did you guess the separate values of ABC? Okay, let us see here. 1 by 1 plus a plus 1 by b plus 1 by 1 plus b plus 1 by c plus 1 upon 1 plus c plus 1 by a. Now we will take LCM in each of these denominators. Each of these denominators. In the first one, LCM will be b, which will be reciprocated to go to the numerator. And here is b into 1, b into a, that is ab. Then b went to top, so it's 1 only remaining. Is that clear? Is that clear? Not clear?
Sir, it's
Yes? Yes, tell me. What's confusion?
no, sir, I got it.
You got it. Same here also. We'll take C LCM. See, if you take C LCM like this, then C plus BC plus 1. You have to write this way, and 1 will be on top. Isn't that?
Yes.
If you take C LCM, it will be looking like that. But we have to take C to the numerator. It will be reciprocal. The same I did here in the first term, and same will be done in the third term. A will come to the top, and here A into 1 plus A into C plus 1. Now we have three fractions, and notice their denominators are quite different. They are quite different. If we take LCM, then we have to multiply all three together. That will be a very time consuming work, right?
Yes.
And we don't know the separate values of A, B and C. We don't know. But we know the product of the three. That is 1. Product of the three is 1. But we don't know separate values. So now what we can do?
We can find their separate values.
Give me a moment. Let's make a change here in the strategy. 1 by A is equal to BC. So 1 plus C plus BC. AC. No, it's okay. We don't need to make a change. One plus A plus AC is equal to 1 by B. B divided by B plus AB plus 1 plus C divided by C plus BC plus 1. In the third one, in place of AC, I can write 1 by B, right? Check it. Is that okay? Because ABC, the product of 3 is 1. So if we take A and C together on the left side and take B to the other side, it will be 1 by B, correct?
Yes.
So let's make this change here. A plus 1 by B plus 1. In place of AC, I wrote 1 by B. So what is the motto? Why I did this? I have an aim. I want to have only A and B in the denominators. In the first one, I already have only A and B. That is already set. In the third one also, now I have only A and B. That is also favorable now. I mean, you can choose any two. You can choose A, B, you can choose B and C, you can choose C and A. Your choice. I have chosen randomly A and B. I am creating the expressions in A and B. So here and here, I got that. Now I have to think of the second one. Is this a possibility to convert the denominator in terms of A and B?
Yes.
Like for C, what can I write for C?
1 by
1 by AB, right? And what can I write for BC?
1 by
1 by A. That's good. If I do so, then the second denominator will also have only A and B. So it may be a favorable condition. I am good doing that in the next step. B divided by B plus AB plus 1. And in the second one, numerator is as it is, no change. But in denominator, for C I'll write 1 by AB, for BC I'll write 1 by A, and the third term is 1. See, everything is set for A and B only. C is vanished in the denominator. Here take LCM again. B is the LCM. That B will go to the numerator by reciprocating. So AB in the numerator, and the denominator is AB. I'll multiply this with this, B with A, so BA. And the middle term will be 1, and this one B into 1, so B. See, the denominators are same in the first and third. 1 plus 1 plus B plus AB, 1 plus B plus AB, right? And now in the second denominator, I'll take LCM. What is the LCM? AB, not just A. AB and A. What is the LCM? AB, right? See, whatever I see and you think, whatever I say and you think it's not clear to you, don't be agree with me. Just say, sir, I don't understand. Then it is my responsibility to explain it to you. If you once tell me, sir, I could not get it, then it will be my responsibility. So don't just be agree with me. B divided by 1 plus B plus AB. I rearranged it. In the second one, I'll take LCM as AB. So what will remain? Let us do it in the rough space here. If I take AB as LCM, then the first numerator will be 1, second numerator will be B, and the third one LCM into 1, that is AB into 1. Does this make sense?
Yes.
This is for denominator part. So I'm going to have LCM AB in the numerator. So I'm getting ABC in numerator. C is already there. AB came from denominator's LCM. And what is remaining here? 1 plus B plus AB. And the third term is already set. No need to change here. 1 plus B plus AB. Now what we see? All the three denominators are same. All the three denominators are same. So now we can take LCM as the denominators are already same. LCM 1 plus B plus AB, because same denominator in 3. 1 plus B plus AB. It's a bit tricky, I understand. In this type of questions, you need greater patience. The first denominator, first numerator B, second numerator ABC, third numerator AB. Now, can you suggest what to do next?
We can out of AB, we can write 1.
Can we take B as common in the numerator?
Yes.
Let's take B as common because B is available in the 3 terms. I'm taking B as common. So what remains after taking B as common? 1 from the first term, AC from the second term, and AB from the third term. So I'll write A. Sorry, say again. Let's do one thing. Why not to put ABC is equal to 1? Right, ABC is equal to 1. So in the numerator I have 1 plus B plus AB. 1 plus B plus AB, and denominator is already 1 plus B plus AB. What's final?
1.
1. That's the answer. If you see anything confusing, let me know.
No, sir.
Okay. Now the next question is, find the value of x if 5 raised to the power x minus 3 times 3 raised to the power 2x minus 8, and that is equal to 225. This is the question. Note it down and start. And try to submit within 4 minutes. You have 4 minutes to submit. It's for more than 4 minutes and you could not. Did you get the clue how to do it? Honestly tell me, did you get the?
Sir, I get a letter. Sir,
Okay, Ahana submitted. So I was asking, tell me honestly, did you get the clue about how to do?
mm,
No?
because sir, no, sorry, the bases were different and
Hmm.
the concepts were
Yes, yes.
different, and there was no reason that we can make them both like same.
Exactly. Actually, this question is having a small trick. If you don't understand that trick, you can't solve this question. That trick is not difficult. It's a very easy trick. But since you are not introduced with this trick, that's why it's difficult for you. Let us understand. What is going on? The problem is that neither the powers nor the bases are same. In our rules, we have seen either powers should be same, both sides, or bases should be same. But in this question, neither bases nor the powers are same. That's the problem. 5 raised to the power x minus 3 times 3 raised to the power 2x minus 8, and that is equal to 225. We should try in such a question to factorize a bigger number, always in terms of prime factors. If we do prime factorization for 225, I hope you remember 225 is nothing but 15 into 15, right?
Yeah.
15 square, and 15 means 5 into 3, 5 into 3. So 5 into 3 comes twice, 5 square into 3 square, can be written 5 square into 3 square. So let's write 225 as 5 square times 3 square. And now see, neither bases are same nor powers are same, so we can't combine them together. They are separate and they will be separate. We cannot combine them together. That's the challenge. But see the technique. Technique is that if you have a into b on the left side and on the right side you have a raised to the power m into b raised to the power m, you can compare wait, you can directly compare first factor with first factor. This is another trick. Notice. Please come on. First factor with first factor, second factor with second factor. This is another trick. This is the trick for this question. Not only the whole base, both sides, but we can compare their factors separately. But when they have same bases for the two factors, like their first factor has base 5, both sides, and their second factors also have same bases. So in this case, in such a case, we can compare their corresponding factors and mention it here, comparing the factors. Comparing the factors. They are equal, na? Left hand side is equal to right hand side. So their values must be same. Their values must be same. The value of on the left, the value on the right are same. That means 5 raised to the power x minus 3, the first factor is equal to the first factor, 5 square. And Similarly, their second factors will be same. Did you understand this trick?
Yes.
So next time when you see the situation similar, you can do so. Now in the first one, their bases are same. Let's remove their equal bases. X minus 3 on the left, 2 on the right gives x is equal to 5. And the second one will give the same answer if this question is valid. Remember, this is the validity of the trick. We have applied a trick, and if our trick is valid, or we can say if the situation is possible, if this situation question is possible, then here and here we will get the same value of x. But suppose in a case we get different values of x here and here, that means the question itself is impossible. This equation is impossible. The product of these two cannot be equal to 225. That will be the meaning. I am telling you the validity. Remember, I am telling you validity. If you are getting different values of x here and here, that means question itself is wrong and no one can solve it. Here 2x minus 8 is equal to 2. So, it was 3 raised to the power, okay, 2x minus 8 is equal to 2. So, 2x will be equal to what? 8 plus 2, 16. Right?
Yes.
My fault. My concentration lost. It's 10 now. You also said yes.
Myra said I was just saying.
Be present. 8 plus 2, 10. So x is going to be 5. Same value. Same value means our method is valid and question also is possible. Same value means this. If they are different, that means question is not possible. This situation is not possible. So finally in that case we will write the question itself is wrong. Okay. So we are done. We got finally the value of x. If you get any question, let me know.
Sir, in the second step I wrote 25 into 9 because I knew the answer would be 25. Is that correct? 2 to 5, is that correct?
You wrote 25 into 9. That's okay. That's good. No problem. Because 5 square is 25 and 3 square is 9. So 25 into 9 is again okay. No problem with that. You have done till this step, correct. These 3 steps are right. But after that you didn't get away, right?
Yes.
So this was for the first time your experience. Next time when you get the similar situation, now you know how to handle, right? Good. For now, we have to end here only. Okay, so this class ends. Bye bye for now. See you in the next class.
Bye.